Number 1. Is the function continuous at x equals 1? Well, when x equals 1, the function equals, we'll say, 2. So, function of 1 is 2. And the limit as x approaches 1 for this function is 2. And the continuity checklist says that if there's a function that exists and the limit as x approaches that constant exists, and those two values are the same, then the limit exists. And because 2 equals 2, the function is continuous at x equals 1.
All right, number 2. Use the continuity checklist to determine if the function is continuous at x equals -2. So the first thing we need to do is determine if the function exists. So f of -2, let's find -2 on the graph. -2 is here, it does exist, and it is at 2. So f of -2 equals 2. Next we need to find the limit. So the limit of f of x as x approaches -2 equals, obviously it does not exist because A, the lines don't meet, and B, the limits of the different points don't match. So it does not exist. The f function of -2 does not equal the limit of f of x as x approaches -2. Therefore, the line is not continuous at x equals -2.
Does the function of -1 exist? Well, when we stroll over to -1, we see that the point is right here. And we know that it's a closed circle because there was not an open circle to begin with. So, because it's a closed circle and it is on the graph and the point is -1, 0. So far, so good. And then when we do the vertical line test, we see that there's no other point. So the function of -1 definitely exists.
Number 4, is the function defined at x equals -2? The function of -2 equals, let's go to -2, the function is defined and it's 2.
So the question is, state how continuity and domain are related. And continuity and domain are related like those annoying best friends that can't go anywhere without each other, because if a function is not within the domain, it is not continuous. A function that is continuous within its domain is a continuous function. So if you have a graph that has a point that has a hole in it, that point is undefined, and that is where the graph is discontinuous. So to be continuous, you have to be within the domain.
We need to determine where the function is continuous at f of x equals 5 over the square root of 7x minus 2. So what we need to do is set the denominator equal to 0. So 7x minus 2 equal to 0. So we can square both sides. So the square root of 7x minus 2 squared equals 0 squared, which would be 7x minus 2 equals 0. So 7x equals 0, x equals 2 over 7, plus or minus. The function is continuous at all real numbers except for x when x equals plus or minus 2 over 7.
Whatever that word. Okay. This question says, determine where the function is continuous for the function g of x, which is x minus 3 all over x squared minus 13x plus 42. As we discussed in a previous problem, the function is continuous within the domain. And for this problem, the only thing that would make this function undefined is if the denominator was equal to 0. So that's exactly how we're going to figure out where the function is continuous. So we take the denominator and set it equal to 0. So how do we do that? Easiest thing to do is to factor. Since we see that this is a binomial function, two numbers that equal 13 that multiply, negative 13 that multiply will be plus 40, positive 42 is negative 7 and negative 6. Because 6 plus 7 equal 13, and the two negative signs when you multiply them together would be positive 42. So x equals 7. How did I do that? Let's backtrack a little bit. Whoop, that's ugly. Erasing the board. So you subtract 7 from both sides. Well, it's a good thing we did that. Oh, no, you add 7. Add 6. And you get x equals 7, x equals 6. And so when we test one of these points, for example, 7 squared minus 13x, minus 13 times 7 plus 42. 49 minus 91 plus 42. Negative 42 plus 42 equals 0. So this point is true. We can assume that 6 is also true. So we know that the function is continuous for all real numbers except when x equals 7 and 6. So